So if we are, for example, interested in cubic equations, we can ask how to solve cubic equations. Nice is okay. Uh, Here we are given a general equation. So that is solving a cubic equation means finding the roots of an equation ax cubed plus bx squared plus cx plus d equals 0. So there is 4 possible coefficients. Highest degree term is third degree of the variable. And there are a few main methods depending on how complicated the equation is. Try simple factoring first. It's easiest cases. The equation is nice, has small values like x equaling 1 minus 1, 2 minus 2. So often one is given some simple equation, but of course there's infinitely many options. So x cubed minus 6x squared plus 11x minus 6 equals 0. So if we try 1, does it work? X equals 1 is a root, so we tried it out and it worked because we plugged it into the equation simply. Then we can divide by x minus 1 to reduce it into a quadratic. So we can then, when we divided it, which is not shown here, we actually get a second degree polynomial in the multiplication of it because we divided it by a first degree polynomial. And this is already factorable. This is a nice example. That's the whole idea. Then we can factor it. Again, not shown here why, but that's the way it goes. And then we have any case when the parentheses is equal to 0 is a solution. So this would be 1, 2, 3. So these 3 solutions. Or we can use substitution to simplify. Depressed cubic. So that's for harder equations. We can transform it. Interesting. So we can do x equals t minus b over 3a. So this t is newly introduced. Wasn't a coefficient, and wasn't in variable in the initial equation. So t didn't appear in the equation itself. We introduced it. So this removes the x squared term and gives t cubed plus pt plus q equals 0. And then solve using a formula. There's a formula for cubic equations actually. So you can search that. Cubic formula. Oh, here it is. Nice. So basically it's explicit formula. Cardano's method. So t cubed plus pt plus q equals 0. If you have such form, we can solve using cubic formula. But what equation did we have before? I mean, yeah. Well, anyway, because if we don't have the x squared term, we can use this formula. That's the idea actually here. We see that we use the transformation. We remove the t squared. There's no t squared. There's only t cubed and then t to the first actually. So that's interesting insight. Graphing and numerical methods, that's kind of graphing it out and then trying to trace back the result, but it's not exact algebraic, let's say. Use a calculator or graphs find approximate roots. Yes. Special cases. If d is 0, factor out x. So where is d? If d is 0, so the base case is if there's no constant term of x to the 0 degree. Then factor out x. Then because we only have terms of at least x to the first, then we can factor out x, and we do x times the quadratic. So that's a special case, a simple case. Not necessarily simple, but it's simpler than having a constant term. Actually, when you think about it, when you don't have a constant term in a cubic equation equaling 0, you can always factor out the x to the first, because there's at least x to the first, so it can be divided directly by this x to the first without any other terms. And if symmetric, try substitutions like x plus 1 over x. What substitution did they show? T minus b over 3a, okay. So, and summary, try factoring first. If that fails, reduce to quadratic. If still hard, use substitution plus cubic formula or approximate numerical. Let's ask, is there a universal explicit formula for cubic equations? So we have to take it to base form. We want the coefficient of x cubed to be 1. And we have the Cardano's formula, but one that can take a polynomial with second degree included. Yes. Oh, okay, so it's not so simple. It's not so simple anymore. So it actually gets harder. So, the explicit formula with just simple expressions is actually when you remove the second degree. You ask about a formula that works for x squared included. So we have to write it in terms of Cardano's method. So if capital C is 0, then C is square root of cube root of delta 1 over 2. And then what they said delta 1 is all this. So there's intermediate quantities. And then there is all this. So that's a lot to delve into. So it's actually not so easy.